Okay, today we are looking at section 4.2. This is the first part of it. Our learning goal today is that we want to be able to add, subtract, and multiply polynomials. The second part of this that we're going to look at on Thursday will be using Pascal's triangle to expand binomials. So the first problem here, we just have a polynomial in the first part, a polynomial in the second part, and we want to add them. If we're adding polynomials, it's really not that difficult. We're just going to combine our like terms. So here's our first term, here's our second term. We're just going to add those because they're alike, so that gives us 3x squared. The next type of term we have is just the x terms, and we're going to combine those. What do we get? Just what? Negative 6x plus 7x, you guys. What is it? We're adding just a plus x. And then the last terms we have that are alike is the 18 and the 8. We add those two, we get 26. So that's our answer. Very easy when we're just adding two polynomials. We just are combining like terms. We had negative 4x squared. Oh, hold on. Minus 1x squared was negative 5x squared. Sorry, I saw that as a plus when I put the circle through it, but that's a negative. All right, make more sense now? I saw some looks of confusion. Okay, there we go. Okay, looking at the next one. Now, the common mistake here is that if we're subtracting this second polynomial, what do I have to do if I'm subtracting this? What happens to all the signs in here? We have to change all of them. I have to distribute the negative through before I combine like terms. So if I have minus a negative, that's going to be a plus 11 to the fourth, 11x to the fourth. On the next one, I'm going to have minus 5x squared. The next term is going to be plus 7x, and the last term is going to be minus 13. That's one of the most common mistakes, is that people do not distribute that negative. Sometimes they only do it to the first term and not to all of them. So don't be one of those people. So now we're going to combine. We have a negative 11x to the fourth, and we have a positive 11x to the fourth. And so what's going to happen to those? They're just going to cancel out, aren't they? I look at my next term, because I want to write these in descending order. X to the fourth is my highest exponent. Then I have minus x cubed. That's going to go next. I'm finished with that because there's no other x cubed. Don't need that anymore. My next like terms are negative 3x squared and negative 5x squared. Yeah, that was a negative. Sometimes that looks like a plus after that circle. So if we have negative 3x squared minus 5x squared, what are we going to have? Negative 8x squared, right? So we did this, we're done. The next like terms we have are 10x and 7x. What's that going to give us? 17x. Done. And our last terms are negative 2 minus 13, which is minus 15. So we are finished with that one. All right, finding products. Well, now we just have a monomial in front of this polynomial. All we have to do is distribute it. So I first of all have to do 2x squared times 2x cubed. What that really means is 2 times x times 2 times x times x times x. This is 2x squared, this is 2x cubed. So what is that when I multiply them? 4x to the fifth, right? So the rule is these numbers get multiplied, but when I have like bases, I add the exponents when I am multiplying. So what's the next term going to be? Minus 2x to the what? Fourth. What's the next term going to be? Is it 6x squared? 6x cubed, because we have, this is x to the first, so we have like bases, so we have to add those exponents, x cubed. And then what is it on the last term? Minus 10x squared. Good. So there's what we get there. Now, if I have to multiply 3 binomials, these are 3 binomials, this is going to take a little time. Not the most fun thing to do, but let's look at it and actually work it out. If I'm multiplying any 3 numbers, like let's say I'm multiplying 2 times 3 times 4, what's the answer to that? 24, right? I do 2 times 3, I get an answer, and then I multiply by 4, correct? So if this is the same thing, I'm multiplying this times this times this. So I'm going to multiply these first 2, get an answer, and then I'm going to multiply by that. So when I multiply these first 2, I'm going to get 12x minus 2x squared minus 18x plus 3x. Before I multiply by the third one, I should probably simplify this first. Question? Oh, thank you. No x on that one, thanks. Just minus 18 there, not x. Okay, so now we should simplify this before we go on. So we're going to have negative 2x squared, and we have 12x and 3x. That's going to give us 15x. And then we just have minus 18. That's what we get when we multiply the first 2. Now we have to multiply by this last one. And so I have to multiply this through by each of these, this through by each of these, and this through by each of these. So sometimes it helps if you actually even have different colors so you can tell what you're doing. I'm going to take this term times both of these to start. That's going to give me negative 8x squared plus 10x cubed. Okay, I'm going to go to my next term now. So now I'm to this one that I have to distribute. So I'm going to have to do that times that. That's going to be plus 60x. And that's going to be minus 75x squared. And then I'm going to go to the last term I have in the first polynomial. Negative 18 times 4. I'm going to do 18 times 2 and then double it. What's 18 times 2? Double it. So it's minus 72. That's an easy way to multiply by 4. And then to do 18 times 5, it's 50 plus 40, which is 90x. And now once we have multiplied all of that, now we just combine our like terms. What's the highest exponent we have? 3. So that term is going to go first. So I'm going to have 10x cubed, done. The next highest one I have is x squared. So I'm going to have minus 83x squared, done. Now I need to go to my x terms. I've got plus 150x, done, and then minus 72. And that's what we get when we multiply those. All right, questions? Yeah, and just be careful at the very beginning with those little things like just 18 on that. All right, let's go to the back. There are some special product patterns that can make things a little bit easier for us. If I have a plus a number and a minus a number, when I multiply this out, a times a is a squared. The outers gives me negative ab. The inners gives me positive ab. The last times the last gives me negative b squared. So what happens to these two values right here? They just cancel out. So do you see how this is the same type of problem? I have x plus 3 times x minus 3. So when I do my first times my first, I get x squared. When I do my outers, I get negative 3x. When I do my inners, I get positive 3x. So what happens with those? They just what? Cancel out. And then what's positive 3 times negative 3? Minus 9. So that's how we get on that one. All right, here's another special pattern. If I have a plus b quantity squared, That's going to be a squared plus 2ab plus b squared. Okay, and here's the reason why. If I have a plus b times a plus b, I do a times a, that's a squared. The outers gives us an ab, the inners gives us an ab, and that gives us a b squared. What is ab plus ab? What's 1ab plus 1ab? 2ab. That's how they got this pattern here. Okay? This is a pattern that's always going to work. You can use it if you want, or you can just write it out. But I want you to get faster at this, guys. That's our whole goal in Algebra 2. Because when you get into calculus, this is just a minor part of a much larger problem. We have to be quick with this multiplication. So we want to do y times y is y squareds. What do the outers give us? Quick. What do the outers give us when we multiply? 4y. What do the inners give us? So altogether, that's what? And then what did the last times the last gives us? 16. So that's what we're going to get when we multiply that out. Look at the pattern. It says we could have done a squared plus 2 times ab plus b squared. You could have used that pattern. Let's try using it on the next one. What's a in this problem? 2t. What's b in this problem? -5. -5. Because the formula says this is a plus, and it's not, so b has to be -5. Now we're going to plug it in. So the pattern has to go a squared plus 2ab plus b squared. That's the pattern we can use if we want to maybe make this go faster. So I'm going to have to do a is 2t. I'm going to square it. Plus 2 times a is 2t. b is -5. And b is -5, and I have to square it. So what is 2t quantity squared? 4t squared. This is all one term here. All of this is together. So what is 2 times 2t times -5? What's that going to give us? 2 times 2 times -5 is what? Right, -20t, and then -5 squared is going to give us plus 25. So if you want to use that formula, you can. If you just want to write it out and do the problem, you can do it that way as well. Now, using the formula on this problem really isn't necessary. It's not that hard to do 2t minus 5 times 2t minus 5. You can do that pretty much just as quick as we did with the formula. But when you are cubing a binomial, it will go much faster if you use this formula. Look at the pattern. A to the third, a to the second, a to the first, no a. No b. B to the first, b to the second, b to the third. Look at the coefficients. 1, 3, 3, 1. This pattern will always hold true. When we work together on Thursday on Pascal's triangle, we're going to develop these formulas for like a plus b to the fourth, a plus b to the fifth, on and on and on. So if I'm going to use this formula for this problem, a is going to be z, b is going to be 3, and I'm going to write down the formula. A cubed plus 3a squared b plus 3ab squared plus b cubed. A is z, so I'm going to have z cubed plus 3 times z squared times 3 plus 3 times z times 3 squared plus 3 cubed. We actually have 1, 2, 3, 4 terms. That's what we're supposed to have. 1, 2, 3, 4 terms. So my first term then is going to be z cubed. So I'm going to have z cubed plus. On this one, I'm going to have 3 times z squared, 9z squared. On the next one, I'm going to have 3 squared is 9 times 3 is 27z. And on the last one, 3 cubed is 27. That's what I would get if I would have just kept multiplying that out. If I would have done z plus 3 times z plus 3 times another z plus 3. All right. We'll come down and do some of these actually instead. Let's look at this one. 3 minus 2 squared, 3x minus 2 times 3x minus 2. Some people still think this is just 9x squared minus 4 or something like that. That is not true, guys. You have to write it twice, and you can either use the formula or you write it twice and you FOIL it out. It's going to be 9x squared. The outers is negative 6x. The inners is negative 6x. That's negative 12x, and that's plus 4. Okay? Questions? Do you notice a pattern with this? Do you know what's going to happen with the outers and inners? What's going to happen? They should cancel out. We do our first times our first is 9y squared. Our outers give us plus 24y. Our inners give us negative 24y. Our last times our last gives us 64. So these two match exactly. One's positive, one's negative. They cancel out. So I just get 9y squared minus 64. Right back up here. It worked out perfectly. All right, I want to change this one to a 2. Make that 3x minus 2. Let's try using this formula. If you want to try it on your own, you can just try it on your own. I'm not going to talk all the way through this one. So try using the pattern that we talked about. Write down what A is, write down what B is. And change that B value to that. Make sure you do exponents first. So work through it, see if you can get this answer. If you don't get this answer, then try to figure out your mistake. And if you can't figure out your mistake, I can help you. Any questions with this? Yes?
Why don't you simplify the 27x squared minus 54x squared?
This is cubed, that's why.
Oh, okay.
Anybody get that one on their own? A couple people did. All right, so by the end of this unit, we want to be able to do this. Let's look at the pattern one more time on this. The coefficients go 1, 3, 3, 1. A to the third, A to the second, A to the first, no A. No B, B to the first, B to the second, B to the third. And then we just plug in, and we should always end up with 4 terms. All right, very good. Stop there.